Okay, so today we're going to be looking at multiplying integers. And many people know the rules for multiplying integers, which are written right up here. And you can read them, but the summary is that if the two factors are of the same type, so two positives, two negatives, you get a positive product. But if you have a positive and a negative factor, or a negative and a positive factor, you get a negative product. And that makes multiplying integers very easy to do. What's missing, though, is that a lot of people don't understand what's actually happening when they multiply. So that's what we're here for today, is to try to figure out what is going on when we multiply integers. So the first case is the positive times the positive equals the positive. And that's the easiest one to think about. So let me just get a question here. We're going to go positive 3 times positive 4 equals, and we know that the answer is positive 12. So there's our question. So what does that look like? So we need to we need to interpret this question. So we have a positive here, and first of all we need to start off with 0. So we're always starting off with 0. So here's my roughly drawn workspace. And in that workspace I have 0. Nothing here. And this question tells me I need to add 3 groups of positive 4. So if I add 3 groups of positive 4, there's one group of positive 4 I'm going to make. And let me just see if I can do that. Yes, and then I'm going to have another group of positive 4 and another group of positive 4. So I have added 3 groups of positive 4. One group, 2 groups, 3 groups, and as you can see the answer is positive 12. And that's basic multiplication, because the multiplication you do when you start learning it in grade 2 or 3 is positive by positive equals positive multiplication. And that's what's happening. That's not very complex. So let's take a look at a different case. Let me just get rid of that if I could. Oh, we don't want that. And let's, there we go. Okay, good. Now let's get in here and let's change this to a negative. And just to be different, let's call this positive 3 times negative 2. And because you know the rules, 3 times, oh boy, 3 times 2 is 6, and a positive times a negative is a negative, so we know the answer is going to be negative 6. Positive times a negative is a negative. 3 times 2 is 6. But what's really going on here? Well, again, we interpret our question and it says add 3 groups of negative 2. So again, I start with 0. And I'm going to do much the same thing that I did in the first question. I'm going to start from 0 and I'm going to add the groups that are required, and in this case it's 3 groups of negative 2. And there they are. 1 group, 2 groups, 3 groups, all of negative 2. So I have 3 groups of negative 2, and when you count them up you see, of course, that's negative 6. So it's important to know how to do the math, but it's also important to understand why it works the way it does, to be able to explain why this answer is negative and not positive. Okay? Starting off with a positive is relatively easy. You're either putting down groups of positives or you're putting down groups of negatives, and that dictates the sign in the factor. It gets a bit more tricky when we start with a negative, so let's look at that next. So let's get rid of this, now that I know how to do this. And we're going to change this question, and maybe we'll go negative 2 times positive 4. And that's going to be a negative 8 if you've been paying attention to the rules. Okay, so we need to interpret this question, and the big change from the first two is that we have a negative here. And I've started off the other question just by saying add 3 groups of positive 4. I can't say that here because I've got a negative sign. So I can't say add 2 groups of positive 4, because if I did that, I'd have positive 8, and the answer isn't positive 8. So what's going on here? There's a negative sign here, so I have to subtract 2 groups of positive 4. Now, when we deal with multiplication, we always start from a value of 0 in our workspace. And with these two cases of multiplication, we can just simply add to the workspace because we have positives. But I need to take away, but I need to subtract from a value that is equal to 0. And that's when I bring up my 0 pairs here. I need to break these up. So now that I've lost track of how many I have, I need to separate them. And I need to have enough 0 pairs here until I can take away 2 groups of positive 4. So I'm going to put this one back together here. Okay, so it looks like I have a lot in this space, but really I have a value of 0. A positive and a negative chip together make a value of 0. So this is 0. But I'm starting from a value of 0 that allows me to do this. Take away 2 groups of positive 4. So I'm going to liberate my groups here. Oops. And then maybe I'll move these down a bit. And yes, I know I'm going to be going out of my workspace, but I am okay with that. Okay, now I still have 0. I still have 0 here because each of these positives is matched with a negative. But with this version of 0, I can take away 2 groups of positive 4. So here is a group of positive 4, and I'm going to take it away. I'll just put it there for now. And here's another group of positive 4 that I'm going to take away. So they are away. And what's left? I've taken away 2 groups of positive 4, and you can see that I have 8 negatives down here. Now let's make it official, and let's just really get rid of them. Well, of course, they're not still joined, so let's just get right rid of them. Now I have fully and completely taken away 2 groups of positive 4, and I have negative 8. So this explains why a negative times a positive is a negative. Now, the case that is perhaps most confusing is this one right here. I multiply a negative times a negative, and I get a positive. Well, what's up with that? Well, if you've understood what's happening here in this third case, then you can kind of predict what's going to happen in the next case. So let's get rid of all this, and let's start a new question where we're multiplying 2 negatives. So let's go back in here and change the value slightly. So let's go with negative 5 here, and let's ramp it up to negative 3. And if you're taking a look at the rules, you see that that's going to end up being a positive, and we're going to have positive 15. So let's just go with that. So a negative times a negative is a positive, and I may need more space here. So why don't I? I'm going to give myself a bit more space. The eraser's not cooperating entirely, but you know, we'll be okay. Instead of drawing a box, I'm going to leave it open because I think I'm going to need all the space that's on the screen for this. Alright, get down there, you. Okay, perfect. So, I'm going to start taking 0 pairs out, and I know already that I'm going to need 15 0 pairs. So this will take a moment, but I will get this done. just have to note that even though I'm pulling out 0 pairs, that's 2 tiles at a time, and I'm covering a lot of real estate, I'm ending up, all I have is a value of 0. So that's something that we really need to pay attention to, because students will sometimes say there's a lot on the page, so there has to be a big number. It's not a big number, it's 0. So here's my representation of 0. But this representation of 0 allows me to take away 3 groups of -5. Now the 0 pairs are bound together, so I need to do all of this, and in one fell swoop I can do this. So here is a group of -5 that I'm going to take away. Whoop, there it goes. Here's another group of -5 that I'm going to take away. There that goes. And my last one is right here. So they're gone, and what is left? I have subtracted 3 groups of -5, and what's left? Positives. So when you take away negatives, when the negatives and the positives are bound together, you can't really see the positives. They're there, but they're neutralized by the negatives. When you pull away the negatives and take them away, the positives are revealed, and you can see them, you can use them. They are there for our observation, and that leads us to a positive answer, because the negatives are gone, the positives remain. And that's what's happening when we multiply a negative times a negative, and that's why it's a positive. So it's good to know how to do this. It's good to know how to multiply integers, but it's better to know why the answer is what it is and what is actually happening in the question that leads to a positive or a negative.